Welcome to the session. The session topic is problem, test and other. So in the previous session, we have seen how to solve a problem on the Gaussian integration. So the today's session's objectives are to learn the problems on Newton's forward and backward difference formula, to learn how to solve the problems on the divided difference formula, and to learn to solve the problems on the trapezoidal and Simpson's 1/3 rule. Also to understand how to solve the problems on Gaussian integration. So the session outcomes are, so students will learn to solve the problems on Newton's forward difference formula. So we'll know how to solve the problems on Newton's backward difference formula. So you'll able to learn how to solve the problems on divided difference. So students will learn how to solve the problems on the trapezoidal rule. So you'll know how to solve the problems on the Simpson's 1/3 rule, and you'll know how to solve the problems on the Gaussian integration. So we'll see first the problem on Newton's forward difference formula. The question is, find f dash of 3 and f double dash of 3 for the following data, that is the first derivative and the second derivative. The data given is x values are 3.0, 3.2, 3.4, 3.6, 3.8 and 4.0. The f of x values given are minus 14, minus 10.032, minus 5.292, minus 0.256, 6.672 and 14 respectively. So for this problem, the solution is that we know that your x0 is equal to 3. x0 value is 3.0, which is nothing but 3. And to calculate h, we use the form. So if you want to calculate your h value, it is nothing but your interval difference. So here 3.2 minus 3.0 is nothing but 0.2. So and your x value is 3 because we have to find f dash of 3. So therefore x value is 3. And to compute your p value, we have the formula p is equal to x minus x0 divided by h. That is 3 minus 3 divided by 0.2. So we get 0 as your value result. So next we have to write the difference table. So in order to write your difference table, first you take your x values and f of x values we are going to write. Then we have to find, that is delta f values, then delta square f values, delta cube f values, delta to the power 4 f values and delta to the power 5 f values. So how we are going to compute, that is, so minus 10.032 minus of minus 14 if we do, so we get a result 3.968. Then for the next value, minus 5.296 minus of minus 10.032, we get 4.736. The next minus 0.256 minus of minus 5.296, we get the value 5.040. Then 6.672 minus of minus 0.256, we get value 6.928. 14 minus 6.672, we get the value 7.328. So difference table is constructed by just taking the difference, that is one value minus the other, that is your y1 minus y0 or y2 minus y1. So we compute the values like that. So you can see in your fourth column, that is your delta square f values, So we have got the value, that is by taking the difference. 4.736 minus 3.968 gives you 0.768. 5.040 minus 4.736 is equal to 0.304. Then 6.928 minus 5.040 will give you minus 1.888. Then 7.328 minus 6.928 gives you 0.4000. So these are your delta square f values. So to compute your delta cube f values, so we take a difference of your delta square f values, that is 0.304 minus 0.768 will give you minus 0.646. Then minus 1.888 minus 0.304 gives you minus 1.584. Then 0.4000 minus of minus 1.888 gives you minus 1.488. So to compute the values of delta to the power 4 f values, we have to take a difference of delta cube f values. So minus 1.584 minus of minus 0.646 gives you 2.048. Then minus 1.488 minus of minus 1.584 gives you minus 3.072. Then we have to compute delta to the power 5f values. So for that you have to take a difference of delta to the power 4 f values, that is minus 3.072 minus 2.048 gives you minus 5.120. Then we have to use the formula. So in the formula we have to substitute the values. So we have the formula f dash of x0 is equal to 1 by h into, so we have 1 by h into delta f0 minus 1 by half into delta square f0 plus 1 by 3 into delta cube f0 minus 1 by 4 into delta to the power 4 f0 plus 1 by 5 into delta to the power 5 f0. So here they have asked for the value, that is 3.0. So f dash of 3.0 is equal to, so you get 1 divided by 0.2 into, so 3.968. So we will substitute the values that we have got in the difference table. See here you can see in the difference table only the topmost values is being highlighted, so it is been in the bold. Only these values we consider in the Newton's forward difference formula. So your delta f value is 3.968. So we have used that value 3.968 minus half into, so your delta square f0 value, that is 0.768 plus 1 by 3 into, so delta cube f0 value is minus 0.464 minus 1 by 4 into your delta to the power 4 y0 value is 2.048 plus 1 by 5 into minus 5.120. So we substitute all these values and we calculate it. Finally, we get the result, that is f dash of 3.0 is equal to 9.4667. So to calculate for the second derivative, we have the formula, that is 1 by h square into delta square f0 minus delta cube f0 plus 11 by 12 into delta to the power 4 f0 minus 5 by 6 into delta to the power 5 f0. So for these we substitute the values, calculated, we get the result 184.4. See, next we'll see the problem that is based on Newton's backward difference formula. The question given is the following data, it represents the function f of x is equal to e power 2x, and the given data is x is equal to, that is 0, 0.0, 0.3, 0.6, 0.9 and 1.2, f of x values are 1.0000, then 1.8221, 3.3201, 6.0496, 11.0232. For this, we have to find f dash of 1.2 and f dash of 0.9 using the backwards difference method. See, the difference table we have to construct first in the solution. For that, we write your x values and then the f of x values in your second column. In the third column, you can see you have, that is delta f, then next delta square f, then delta cube f, then delta to the power 4 f. See, all these values you are going to compute, that is by taking the difference. So for the previous column, you are going to take the difference and write your result. That is, to calculate your inverse delta f values, so what we do is 1.8221 minus 1.0, so you get 0.8221. Then 3.3201 minus 1.8221, we get 1.4980. 6.0496 minus 3.3201 is equal to 2.7295. Then 11.0232 minus 6.0496 is equal to 4.9736. So the next column we have, that is delta square f values. So for this, you have to take the difference of your delta f values. For the first value, we have 1.4980 minus 0.8221 is equal to 0.6759. Then 2.7295 minus 1.4980 is equal to 1.2315. 4.9736 minus 2.7295 is equal to 2.2441. So these are your delta square f values. Then delta cube f values, to compute that, you are going to take a difference of your delta square f values, that is 1.2315 minus 0.6759 is equal to 0.5556. 2.2441 minus 1.2315 is equal to 1.0126. So these are your delta cube f values. To find your delta to the power 4 f values, we take the difference of your delta cube f values, that is 1.0126 minus 0.5556 is equal to 0.4570. So you can see the last values has been highlighted, it is in the bold. Only the last values are considered in the Newton's backward difference formula. The next, so here the step length, that is the h, is equal to 0.3. So h value is 0.3 and at x is equal to xn is equal to 1.2. So we have to compute for 1.2. So you use the formula, that is Newton's backward difference formula. So f dash of xn is equal to 1 by h into delta fn plus half into delta square fn plus 1 by 3 into delta cube fn plus 1 by 4 into delta to the power 4 fn plus 1 by 5 into delta to the power 5 fn, plus it goes on. So we substitute all the values and then we get the result, that is f dash of 1.2 is equal to 21.8248. Then at x is equal to xn minus 1 is equal to 0.9. So they have asked you to calculate for your x is equal to 1.2 as well as for your x is equal to 0.9. We have to calculate the first derivative. So we have f dash of x n minus 1, which is nothing but f dash of 0.9. We have the formula, that is 1 by h into, so delta fn minus half into delta square fn minus 1 by 6 into delta cube fn minus 1 by 12 into delta to the power 4 fn. So it goes on. So we substitute the values. The h value is 0.3, that is your step length. Then your delta fn value, so delta square fn value, delta cube fn value, and delta to the power 4 fn value is being substituted and you calculate. So we get the result 12.1490. See, next problem we have, that is based on the divided difference formula. The question given is, find the first and the second derivative at x is equal to 1.6 for the function represented by the following tabular data. The data given are x is equal to, that is -2, -1, 0, 1 and 3. These are your x values, and f of x values are 9, 16, 17, 18 and 44. So these are the values that is given. We have to find the first as well as the second derivative at x is equal to 1.6. So first we have to construct the divided difference table. So in the first column we write your x values. In the second column we write your f of x values. The next is your, for your first derivative, then we have second derivative, then your third derivative. For the first derivative, what we do, that is to calculate this, we make 16 minus 9 divided by -1 minus of -2. So you get the result, that is 7. Then 17 minus 16 divided by 0 minus of -1, we get the result 1. Then 18 minus 17 divided by 1 minus 0, so we get result 1. Then 44 minus 18 divided by 3 minus 1 is equal to 13. So to calculate your second derivative, you use the values of your first derivatives. That is 1 minus 7 divided by 0 minus of -2, we get -3. Then 1 minus 1, 1 minus 1 divided by 1 minus of -1, that is equal to 0. Then 13 minus 1 divided by 3 minus 0. So we get the result 4. So to calculate your third derivative, so you have to make use the values of your second derivatives. That is 0 minus of -3 divided by 1 minus of -2 is equal to 1. Then 4 minus 0 divided by 3 minus of -1, we get the result, that is 1. So this is the divided difference table. Then we have to use the formula for your divided difference table. Substitute the values and calculate the result. So here, according to the given data, x0 is equal to -2 and your x1 is equal to -1 and the x2 value is equal to 0. So we have to substitute your x is equal to 1.6 because they were asked for 1.6. You have to calculate the derivative. So f dash of x is equal to, the formula is f into, that is x0 comma x1 plus x minus x0 plus x minus x1, then f of x0 comma x1 comma x2 plus x minus x0 into x minus x1 plus x minus x0 into x minus x2 plus x minus x1 into x minus x2 into f of x0 comma x1 comma x2 comma x3. So we substitute the values, so in the above equation, then we get the result, that is 7.68. So your f of x0 comma x1 is nothing but your first values in your table. So you can see in your first derivative the value 7, the second derivative -3 and the third derivative, that is 1. So these values are used, that is in your equation, that is f of x0 comma x1 is 7, you can see that. Then f of x0 comma x1 comma x2, that value they have used. Then f of x0 comma x1 comma x2 comma x3, that is for your second derivative whose value is 1. Those values we will substitute and we get the result, that is 7.68. Then again we substitute, that is x is equal to 1.6 in the formula, that is for your second derivative. The second derivative formula is given by, that is 2 into f of x0 comma x1 comma x2 plus 2 into x minus x0 plus x minus x1 plus x minus x2 into f of x0 comma x1 comma x2 comma x3. So the values we will substitute in the above formula and we get the result, that is for the second derivative 1.6. So f double dash of 1.6 is equal to 5.6. So next we have a problem based on your trapezoidal rule. Calculate the value of the integral, that is log x dx, using your trapezoidal rule. The limits given is 4 and 5.2. So here what we have to do is, we have to take your h is equal to 0.2. So here you are dividing 4 comma 5.2 into 6 equal parts. So your 4 is your lower limit and 5.2 is your upper limit. So this we are dividing it into 6 equal parts. So then the values of the log x, that is for each points of your subdivisions, it is as follows in your table. So you are making totally 6 equal parts. So we have x values as 4.0, 4.2, 4.4, 4.6, 4.8, 5.0 and 5.2. So you can see that your lower limit is 4.0 and your upper limit is 5.2, and it is being equally divided into 6 parts. So for this we have to calculate for the log x, that is log x value. So log 4.0 value is 1.38629. So log 4.2 is 1.43508. Log 4.4 is 1.52605. Log 4.6 is 1.56861. Log 4.8 is 1.60943. Log 5 value is 1.60943. Log 5.2 value is 1.64865. So we have to use the trapezoidal rule. So trapezoidal rule, the formula is given by, that is h by 2 into y0 plus 2 into y1 plus y2 plus y3 plus y4 plus y5 plus y6. So here the values are substituted. So your y0 value is 1.38629 plus 2 into, so what is your y1 value? That is 1.43508. Then your y2 value is y2 value is 1.52605. So your y3 value, so y4 value, y6 value as well as your y6 values, all these values are substituted. See, you substitute and you calculate. So we get the result, that is 1.827648 has the result. See, next we'll see a problem that is based on the Simpson's 1/3 rule. See, evaluate the integral e power x dx by the Simpson's 1/3 rule. So here the integral that is given is in the limits 0 and 4. The lower limit is 0 and the upper limit is 4. So in the solution what we have to do is, we have to divide the integral, that is 0 comma 4, into 4 equal parts. So we divide it into 4 equal parts. So that what happens, your width, that is h is equal to, when you make 4 minus 0 divided by 4, so you get the result, that is 1. So in order to compute your width, so we use 4 minus 0 divided by 4 is equal to 1. So therefore the interval, that is h, is nothing but the interval difference is given by 1, and we have to divide it into 4 equal parts. So therefore we have the x values 0, 1, 2, 3 and 4. You can see the values are 0, 1, 2, 3 and 4, and e power x we have to compute. So e power 0 is 1, e power 1 is 2.72, e power 2 is 7.39, e power 3 is 20.09, e power 4 is 54.60. So we get the values. Then now by using the Simpson's 1/3 rule, so this formula is given by, that is h by 3 into y0 plus 4 into y1 plus y3 plus 2y2 plus y4. So here we substitute the values of h is 1, y0 value, y1 value, y3 value, y2 value as well as y4 values. We substitute in your Simpson's 1/3 rule and we get the result, that is 53.87. So next problem we have, that is on a Gaussian integration or the Gaussian quadrature. So use the Gaussian quadrature 3-point formula to evaluate I is equal to integral of e power minus x by 2 into dx. So the limits given are -2 and 2. So for this the solution is a is equal to -2, that is your lower limit, and b is equal to 2, that is your upper limit, and we have the f of x is equal to e power minus x divided by 2. So here by using your quadrature 2-point formula, that is given by I is equal to b minus a divided by 2 into w1 into f of x1 plus w2 into f of x2. So here we will calculate the x1 value by the formula x1 is equal to b minus a divided by 2 into z1 plus b plus a divided by 2. So to calculate the x2 value, we use the formula b minus a divided by 2 into z2 plus b plus a divided by 2. So your w1 is equal to w2 is equal to, the value is 1, and your z1 is equal to minus 1 by root 3, and the z2 is being given by 1 by root 3. So the values what we have, we substitute the values. Here the x1 is equal to, so x1 value, we have the formula, for the above formula we substitute all the values, that is 2 minus -2 divided by 2 into minus 1 by root 3 plus 2 minus 2 divided by 2, so that gives you minus 2 by root 3. And to calculate your x2 value, so you substitute your values, that is b value, a value, z1 value, z2 value, you are going to substitute and get your result. So we have 2 minus of -2 divided by 2 into 1 by root 3 plus 2 minus 2 divided by 2, you get, that is 2 by root 3. So this x1 and x2 values what we have calculated, you have to put this values into your formula, that is your Gaussian quadrature 2-point formula. So we have I is equal to b minus a divided by 2 into w1 into f of minus 2 by root 3, that is your x1 value, plus w2 into f of, that is 2 by root 3, that is your x2 value. So we are substituting the values. Now we are going to put your a value. A value is -2, your b value is 2, your w1 and w2 values are 1, and we also put your f of x values, that is in your above equations. So when you substitute all the equations that is in your above equations, so we get the result, that is 4.6854. So next we'll see a problem on Gaussian quadrature 3-point formula to evaluate I is equal to integral of 1 by 1 plus x dx. So here the limits are 0 and 1. So in the data given, your a is equal to 0 and b is equal to 1, and then your f of x is equal to 1 by 1 plus x. See, the Gaussian quadrature 3-point formula is given by I is equal to b minus a divided by 2 into w1 into f of x1 plus w2 into f of x2 plus w3 into f of x3. So here we have x1 is equal to b minus a divided by 2 into z1 plus b plus a divided by 2. Then x2 is given by b minus a divided by 2 into z2 plus b plus a divided by 2. Then x3 is given by b minus a divided by 2 into z3 plus b plus a divided by 2. So here the z1 value is minus root of 3 by 5, z2 is equal to 0 and z3 is equal to root of 3 by 5. W1 value is equal to 5 by 9, W2 is 8 by 9 and W3 is equal to 5 by 9. So first we'll calculate your x1 value, x2 value and x3 values. Then the x1 values, the x1 values, your w1 values and your f of x values will substitute in your Gaussian quadrature 3-point formula. See, your x1 is equal to, we have 1 minus 0 divided by 2 into minus root of 3 by 5 plus 1 plus 0 divided by 2 is equal to, we get 0.1127. Then x2 is equal to 1 minus 0 divided by 2 into 0 plus 1 plus 0 divided by 2 is equal to 0.5. So x3 is equal to 1 minus 0 divided by 2 into root of 3 by 5 plus 1 plus 0 divided by 2 is equal to 0.8873. So now we'll put the x1, x2 and x3 into your Gaussian quadrature 3-point formula. So we get I is equal to b minus a divided by 2 into w1 into f of 0.1127 plus w2 into f of 0.5 plus w3 into f of 0.8873. So now putting your a value, b value, w1, w2, w3 and f of x values in your above equations. So we have I is equal to 1 minus 0 divided by 2 into f by 9 into 1 divided by 1 plus 0.1127 plus 8 by 9 into 1 divided by 1 plus 0.5 plus 5 by 9 into 1 divided by 1 plus 0.8873. So when you calculate this, we get the result 0.6931. So in this session, we have seen how to solve a problem on Newton's forward difference formula, problem on the Newton's backward difference formula and problem on the divided difference formula. So problem on your trapezoidal rule, problems on your Simpson's rule and the problem on your Gaussian quadrature using 3-point as well as 2-point formula. So these are the references. Thank you.